Graphing relationships. We have two vocabulary words or terms for this lesson, and they're two different kinds of graphs. So you're either going to have a continuous graph, which is going to be a line or a curve, okay? And that's going to be a continuous graph, and that's a continuous graph because there is data on every point on this line. So the idea is that you're not ever going to have a place where it doesn't make sense to have data. Okay? A discrete graph will have places where it doesn't make sense to have data. Okay? And this might look like a scatter plot, or it might look like it's almost a line, right? All your data points kind of form a function, but the idea is that there's no data in between them. All right. This could be maybe price for a ticket. Right? And it makes sense for us to have a price for one ticket and for two tickets and for three tickets, but there's no way to buy 1.5 tickets. So there's no data in between those. Okay? Whereas a continuous graph, this might be seconds, okay, on the x-axis, and this could be height. Okay. So as time goes on, this is the height of whatever. Maybe this is a baseball that somebody throws up into the air. Right? It starts off low to the ground, it goes up, it reaches the point where it stops having upward momentum, gravity starts to take hold, and it falls back down. Okay, and then maybe this is a elevator, right? It takes longer, but it just keeps going up and up and up and up and up, and then maybe it stops somewhere here, right? But the point is, there would be data. I would be able to see how high the ball is at 1 second, at 2 seconds, at 1.5 seconds, at 1.25 seconds, right? All of those places will have data, okay? There will be some height that we can look at. All right, concept 1, relating graphs to situations. So now when we are looking at a graph and trying to come up with a situation, or looking at situations and trying to choose the graph that represents it the best, what we want to look at are keywords, okay? And then we want to kind of progress from the left to the right, all right? Our first job whenever we're doing anything with graphs is to look at the axes, look at the labels, okay? See what they are, make sure you understand what the graph is about, okay? If the x-axis is time, right, so if this is time on the bottom, time, then it makes even more sense to read it from left to right, as this is a progression through time, okay? All right, and then you're going to list your keywords in order. So if you're looking at a graph, you're going to list those keywords, or if you're reading a situation, you'll look for these kinds of keywords, and then try to match them up with your graph. So if this is the graph I'm looking at, it's got water level on one side, or water level for the y-axis, time for the x-axis, okay? I'm going to be looking for these, or using these keywords, all right? So I'm going to start off, and this looks like this is a constant, right? It stays flat here. So that looks like it was constant, or it stayed the same. Okay, sometimes in a situation it'll get described as what its starting point is, right? So maybe the water in my pool started off 3/4 full, and then now we're going down a little bit, so this would be some situation that's causing us to lose our water level. Maybe we had some really warm sunny days and it's evaporated, right? Our water level's going down over time. Now we're up to a pretty sharp increase. So this could either be me refilling my pool, or maybe we had a day or two of really rainy weather, so the pool filled back up again, and then it stayed the same or was constant for a while. And then this looks like maybe me draining it, or for whatever reason, that pool, that water level dropped sharply, right? And went all the way to the end of the graph, right? All the way to most likely 0 if my graph were labeled.